We're going to learn about information gain. We're also going to learn how it's used in machine learning, what it means for search, how the information gain score is calculated, what are the different ways to apply this concept, and how you can pivot your content strategy or your keyword research strategy to incorporate how Google uses this concept in search. Let's start with what is information gain. Information gain is a score that measures how much additional useful information a new document or otherwise a web page provides to users who have already seen other pages on the same topic. There are already several conditions that need to be met in order for the score to be relevant, even though we will see other ways that Google uses the score later on. But the conditions, if you quote them, are the user that already has some knowledge about a topic, has already seen some information about a certain topic, and now the information gain score is used in order to determine what new information is presented to that particular user whenever they are performing a query. And that information gain score is part of the ranking determination of what new pages to show that particular user. It might be useful to look at some patterns and see what they mean for search in order to better explain this concept. The information gain score, whenever applied to a document, indicates how much new information it provides beyond what the user has already seen on this topic. This score can be calculated by applying the document to a machine learning model. We will explain a little bit more how this works in a moment, but essentially, what different patterns will tell us is that documents are presented to the user based on their information gain scores, prioritizing certain documents or web pages that are likely to provide the most new information to the user and keep them engaged for longer. In order for this kind of analysis and scoring to be done, Google will actually classify documents into viewed by the user, and those are the web pages that they have visited already, and not viewed by the user, and then perform the analysis. How is the actual information gain score calculated? The concept behind the information gain score comes directly from machine learning models that are called decision trees. Constructing a decision tree is all about finding an attribute that returns the highest information gain. And the aim of this score is to show the item with the highest variance from the comparison and identify how much variance this data has, which is used to determine and define the randomness in the data. And there are several different data points that are considered. One is the page contents of relevant pages. Another data point is the salient, the extracted information. There can also be a semantic representation of this information that's extracted, which could be an embedding, a bag of words. It could be a histogram generated from words and phrases. It could be entity data as well. And some of these data points are used for a machine learning model to generate that information gain score. And how this actually works in practice, speaking from a machine learning modeling standpoint, is that if you have a system that is tasked with calculating an information gain score, that system could have two parts, and that is simplifying it quite a lot. But the first part will represent each document as a semantic feature vector or embedding, or otherwise a numerical representation that captures the meaning of the document. And these can be generated by models like Word2Vec, which actually map words or documents into vector space based on the semantic relationships that they present as part of the text. And so the second part of this system will actually take this information, the vectorized information, and process it through a neural network, which will take the input of the documents as vectors, of course, documents that the user not viewed already, and documents that the user has viewed, classify them, process them, and output an information gain score based on what is reflected within those documents. A different patent also mentions that Google will use information gain scores to identify duplication in web pages, and it will actually use that score to deduplicate search results. This type of system will be adapted to identify phrases that are related to each other based on the phrase's ability to predict the presence of other phrases in the document. What this means is if there is a co-occurrence rate of certain phrases in a document, two phrases that are related, and if that co-occurrence passes a certain threshold, essentially Google collects and processes phrases that are used in a document and classifies them into good phrases, incomplete, possible, and so on. The information gain score in this implementation is calculated as a ratio of actual co-occurrence rate to expected co-occurrence rate, which is a prediction measure that they have determined. The Two phrases are considered related where the prediction measure exceeds the predetermined threshold, in which case the second phrase has significant information gain with respect to the first phrase. Phrases that are semantically related are those commonly used to describe a certain topic or a concept. Like, for instance, the President of the United States and the White House are frequently co-occurring phrases. And information gain scores are also used in another implementation in phrase-based parsing of documents that is done with the same aim, to identify spam from ham or otherwise to reduce duplication in search results. In this patent specifically, there is an information retrieval system that uses phrases to index, retrieve, organize, and describe documents. Phrases are identified that predict the presence of other phrases in documents. Documents are indexed according to all of the phrases that are included in them. A spam page is identified based on the number of related phrases that are included in it. Essentially, Google uses the same system that we described, the same score that we described in the previous patent. And we can see this from the visualizations that they have in both of these patents, even though they are different. But in this particular implementation, they also do something else. They count how many phrases are duplicated across their entire document collection that references the same phrases. They then filter the index and personalize the results based on this. Another way that Google uses information gain scores is to expand entity collections and related entities. And of course, these scores are also actively used in knowledge graph expansion. This patent specifically shows that a system that will automatically generate groups of related entities, like products or services, by analyzing a data graph where entities are connected by edges. And it will do them by first identifying the set of entities and constraints representing shared paths within the knowledge graph, then creating candidate collection definitions by combining these constraints, evaluating the relevance and usefulness of each candidate collection, which is done by actually incorporating that information gain score. And the score in this quantifies the amount of new valuable information the candidate collection provides beyond existing collections. And whenever candidate collections with information gain scores meet a certain threshold, they are stored as valid collections. This method leverages information gain to effectively form and refine collections of related entities, ensuring that each collections offer significant and distinct information. Information gain scores are also used for related query and related entity suggestions. There is a patent that details a method for enhancing information retrieval by incorporating external related phrase information into a phrase-based indexing system. And a key component of this method is the use of information gain to identify and rank related phrases. It works in different steps. The documents are indexed using phrases rather than individual words, which captures more context and a lot more semantic information. The system incorporates related phrases from external sources like thesauruses or domain-specific databases to enrich their index. And then the information gain score is defined same as before in terms of the phrase actual co-occurrence rate versus expected co-occurrence rate. The system calculates this ratio to determine the strength of the relationship between these phrases, how important they are, how often they are used with one another in context. Phrases with an information gain that exceeds the predetermined threshold are considered significantly related. And then the ranking is done for a given phrase where related phrases are ordered based on their information gain scores, which allows the system to prioritize more significant associations. Let's talk about what these actually mean for marketers and how you can apply this concept. Put simply, the pages with higher information gain scores may get ranked higher because they provide more unique and valuable information. This helps prevent users from seeing repetitive information across multiple documents, and it enhances the experience that users have on Google. What we can see from all of the patents and all of the references of information gain scores, they are first of all highly personalized to the user. They are highly contextualized to users, their queries, their knowledge, the past pages that they have seen, the user context of the search and the session context as well. And they're also contextualized to specific queries and specific phrases and also to documents as well. When you're thinking about how to practically incorporate information gain as part of your keyword research, firstly, you need a very thorough grasp of entities, attributes, and attribute values or variables, along with a keen understanding of the current information that's available in the search landscape or otherwise the competing pages. All of that is needed in order for you to effectively apply this concept in keyword research. And what this translates to in terms of projects that you need to execute in order to have a good understanding of this concept before you even do any sort of calculation on information gain or otherwise uniqueness is, first of all, identify who you're competing against, not only from a business standpoint, but from an organic standpoint. Do a SERP analysis, do content scraping, do entity analysis, implementation of the EAV model as well, and then calculating the information gain score per article, but also per individual query as well, and mapping the query with the documents that are ranked. And even with this information, you're still missing a key component, which is actually the user personalization component, what the user has seen. So this is something that prohibits the information gain score to be super specific and precise measure that you can use or actually implement. So it is a little bit more vague. But that doesn't mean that it doesn't give us useful information in how to apply it to strategy, which we will talk about in a second. When we're talking about strategic implementation, focus on presenting new or proprietary information as opposed to just replicating the articles that currently rank. Incorporate user research and first-party data as a principle in the content that you produce, and also regularly update content as well. This is another concept, very similarly to knowledge graphs, where we can see very much the difference and the departure from traditional methods and into semantic keyword research. Instead of only focusing on metrics from third-party sources like search volume, you need to actually understand where the information gaps are and fill them through your content. And in the context of information gains, the uniqueness of the content that you can present might be something that is coming directly from your product and your service that you have. Let's take Zapier, for example. Instead of relying on search volume, they had one of the most popular and well-recognized cases of programmatic SEO. Before they created their templated pages, most likely didn't see any search volume for this because a product like them wasn't as popular, maybe didn't exist, that actually shows you how to connect this software with another software. So they couldn't rely on search volume as a metric to show them potential, right? But they knew that this type of information, how to do this thing, exists within the domain of their organization. The uniqueness that they're providing in the context of the entities that are the software mentioned in these pages actually exists within their own organization, and they're just bringing it to the search landscape. This is just an example of how you can find inspiration to expose, if you wish, to the search landscape information that exists only in your organizational domain. But of course, if you address the user's need in terms of search and you also develop your brand at the same time, you can see, as in the case of Zapier, that demand will grow and it will validate the importance of focusing on user intent and behavior as opposed to just looking at metrics, because metrics don't really tell you the full picture and they're backward looking, whereas concepts like information gain actually push you to consider the user, what they might know about the topic already, what information exists in the search landscape, and how you can actually enrich the search landscape with the content that you're creating. Let's talk about some tactics that you can use to improve your content's information gain score. When we talk about content strategy tactics, you can diversify content topics to cover less saturated areas relevant to your audience. You can regularly update content with the latest developments and trends, incorporate also unique insights from expert opinions, from in-depth analysis, or from research that you have. Of course, as in the example of Zapier, you can also write documentation about how your systems work and what you do in terms of case studies if you're a service-based business and so on. You can also curate niche content tailored to specific user interests and address gaps that way, which could be things that we discussed in previous lessons, like honing in on specific user personas and defining them in a very nuanced and specific way and addressing the content needs for those. And you can personalize content recommendations based on user behavior and preferences. And this would require a little bit more of a web dev help in terms of the page design and the user experience on your website. In terms of how you present the content, you can highlight key points using summaries, bullet points, takeaways to further hone in if there is new information or something unique presented in your content. You can use dynamic formats like infographics, videos, or interactive tools to discuss the same concept but from a different angle. This can be a form of uniqueness to your content. In terms of personalization and accessibility, you should aim to provide recommendations that introduce new concepts and perspectives that are very highly relevant to the content that the person is already visiting you on your website. So this is where having a very solid internal linking strategy that is focused on semantics will play a crucial role. You can also diversify the recommendation formats and viewpoints to offer broader perspectives. For instance, if you have a certain article written from the point of view or for targeting different user personas, you can introduce the other points of view to the users that are browsing on your website. And this is very similar to offering advanced guide to an article that is a beginner. For instance, internally linking your beginner, advanced, and expert guides into one. If you have content that is diversified based on user personas, but it's on the same topic, then you could link those as well. You can also offer localized and multilingual content to cater for diverse audiences and improve the accessibility of your content that way. And you can ensure that the content is accessible via various devices and formats, something that we mentioned previously. When it comes to partnerships and collaborators, one way to improve your information gain score would be to collaborate with industry experts and influencers and actually feature their insights within your content. You can also encourage user-generated content submissions and feature them as article additions to expand your content pool with unique perspectives, as opposed to just whenever you're writing article, just regurgitating information that already exists on the web. Let's conclude what we learned. Information gain is a measure that is used to evaluate how much new meaningful information is provided by a particular feature, document, or phrase compared to what is already known. It quantifies the reduction in uncertainty or entropy when additional data is introduced. The score is used across a variety of Google's applications and systems related to search, some related to personalizing the search experience, others related to duplication. Information gain is employed in systems that rank and prioritize documents, phrases, or entities to ensure that the users are receiving the most valuable content related to their knowledge and needs. So it's a very personalized score to the user based on what information they are already accustomed to and what level of complexity presented they're used to. The information gain scores are calculated using different methods, but most often they are comparing an actual versus expected co-occurrence rate of phrases or words or entities, and they are applying machine learning models like bag of words representations and neural networks to assess the informational novelty of content. How SEOs and content marketers can include this concept in their work is by creating unique in-depth content that addresses unexplored aspects of a topic, leveraging user behavior data to identify knowledge gaps, and enriching content with diverse perspectives and updated insights to ensure that it provides maximum value to the user. With that, as usual, I want to thank you for watching, and I'll see you in the next one.